Okay, so let's begin our webinar. And my name is Yiming Chen, and I'm from OriginLab technical support team. And in this webinar, I'm gonna give you a presentation on the peak analysis tools in Origin. And by going through some real world data, I'm going to cover the topics of peak findings, peak integration, peak fitting, 3D peak fitting, and batch peak analysis. So hopefully this webinar will be helpful with your research. Okay, so before the starting of the webinar, I'll just let you know that the recording of this webinar, we will put it on our web page like a few days later, and you can come back to check. And I also want to let you know that this webinar is demoed with the Origin 2020B. So we just released 2020B like a couple of weeks ago. And please come to our webpage to download and try if you haven't. Okay, so let's now begin our webinar. Okay, let's first to check our first example, peak finding. Okay, if we look at this worksheet, we have 3 spectrums, and I plot them as like a line plot, like a stacked line plot here. If you don't know how to make a stacked line plot, it's from the plot menu, basic 2D. It's here, stacked lines by y offsets. Okay, so this is our spectrum, and before I do any analysis, I will just use our this page mini toolbar to change this to a window view. So by clicking this button, you will see now the graph is filling the whole page, and when you drag the edge of the window, the graph will get resized as well. So it's this is a feature in the mini toolbar is introduced in 2020B, and just let you know. Okay, so when you see a spectrum like this, the first thing you will do is just to you want to just simply check the parameters of each peak. You will need to first locate every peaks, and then know like the height, the area, or the width of each peak. So Origin have this nice tool called the quick peaks. This is a gadget. Gadget is like a small tool which operates on the graph. Okay, so let's start with the quick peaks gadget. If we open the dialog, and there are multiple tabs in this dialog, and you can do multiple settings. So before we do any other settings, we just go to the baseline. So by looking at this spectrum, the baseline is almost like a constant. So, and we just set the minimum of the spectrum y value as the baseline. So just leave it as it is, and we can check how this tool is working. Okay, if I click OK, so a yellow box is added to the graph. It's the area of interest. So it's a region of interest. So if we look at the graph, the gadget is applied on the first data set. Okay, and it's on the it's applied on the bottom spectrum. So we see that a lot of unwanted peaks are also found. Then what we do is we are going to adjust the settings to just find those like strong peaks. So to change the settings of the gadget, you just double click on this yellow area to bring up the preference dialog. And we can come to this find peak tab. And so since this spectrum only have the very like separate peaks, okay, so in this scenario, we can just use the method local maximum to locate the peaks. So there are other methods. I will talk about that later in other tools, but right now we just use local maximum as the peak finding method. So for now, like too many peaks are found. That's so because the threshold height is set to 2. So any peaks with a height larger than 2% of the highest peak will be found. So let me just change this to 20. Okay, let's click apply. So now like small peaks are deleted from the spectrum, and this is good to me. So and we can also check other tabs like what quantities you want to get from the list of peaks. For example, I want peak ID, but maybe I don't want the peak rows. It's just index of the data in the worksheet. Okay, so there are a couple of choices, options here, but I will just leave it as it is. Okay, so let me click OK. Okay, so before I'm moving forward, I will just let you know. Right now, the first spectrum is selected, so I can change data to different spectrum on the page by clicking this button. It will move to the second spectrum and to the third spectrum. You will see that for different spectrum, we'll use different peak finding method to find out our peaks. Okay, let's just go back to the first one. Okay, so next thing is you may want to just annotate each peaks, right? So let me first duplicate the graph. Okay, if you wanted to just to put a label on each peak, so here is a option called tag peaks. So if we just click this, you will see a worksheet is generated, and it has all the X and Y values of each peak. And if you close this, the gadget, the annotation of each peaks are still stayed on the graph. Okay. So this is the one thing you can do just to know, okay, where the peak is, and you just want to put a label on it. This is good enough. So if you want to know more information, know more about the parameters of each peak, you can use this, just click this button, new output. You see another worksheet is generated in this result workbook. It gives you all the parameters of each peak, like the X and Y values, height, peak area. That's what we selected in the, if you remember, in the quantity tab. Okay, so now let's, what if we want to check the other spectrum? We can click this button and go to the second spectrum. But it maybe, okay, this peak is not found, and we want to find those lower peaks, and we can go back to the find peak method and maybe change the threshold a little bit lower. And some more peaks are found. Okay, so now we apply different like peak finding method to the second spectrum, and we want these information to be appended to this result worksheet. So we just click new output again. So you will see the peak informations are appended to the existing result sheet. Okay, we can repeat that for the third spectrum. Yeah, we need to change the settings again, double click. In this case, we might the even smaller peaks we are trying to find. Okay, we can just click apply to preview the analysis result. Okay, maybe it's smaller because there's still some peaks are not found. Okay, now all these peaks are found. That's good. Let's click OK to finish it. And again, we can click this new output button to append the result to the worksheet. So we have all the information of all the peaks of all the spectrums right now. Okay. Just to let you know that if you are like apply the same settings, same peak finding method or same baseline settings to all the spectrums, then you can generate the outputs all at once. Simply click new output for all curves that will generate an entire table of all the information of all the peaks. Okay. With this tool, you can also do peak fitting. But for example, if I just want to look at these 3 peaks, okay, I just resize this region of interest and just cover these 3 peaks, and I can click this button and go to fit peaks. There are multiple peak functions that you can choose from. Maybe I will just do a Gaussian fit. It will generate a result table on the top of this graph, gives you all the information of the parameters of the fitted peak function. This tool is neat, but it has very few controls. So you don't have the controls of you want to put the constraints to the fitting parameters, and if there are like hidden peaks, it might not work well. And we have other more sophisticated tools to do that. So right now, I just show you the capability for this tool to do some simple peak fitting. Okay. After this example, let's move to our next example, peak integration. Okay, this is another data. Okay, here are like 5 spectrums, which are the observation power as a function of the energy, and it was taken at 5 different parameters. Okay, again, we use this page level mini toolbar to make it wider, and the spectrum is looking in a full span now. And if we want to like just to scan the spectrum, we can simply press the X key on the keyboard and use the mouse scroll to move back left and right of the spectrum, and you can shift X to move it up and down, and you can use the Z key to enlarge horizontally, and shift and Z to enlarge vertically. Okay. So in this example, maybe scientists want just to check one peak, for example, and he wants to know how the peak parameters are different between these 5 spectrums, and want to for example, make a plots from it. Okay, let's see. Let's use this keyboard keys to just zoom into one peak. For example, I want to locate just this peak. Okay, I just move it to in the middle, and then just make it larger, and use the shift key and the Z key to make it bigger. Okay. Okay, now it's good enough. Then, for example, we want to check. You will see the peak is moving, kind of moving to the right, and its area is increasing as well. So let's see how we are going to calculate the area of each peak, and we also want to know the width of each peak. Okay, let's use another gadget called integrate. Okay, again, in this dialog, we can select the baseline mode. In this case, we just use the endpoint. We use the endpoint of this each peak to just connect them as the baseline. You can define the number of the endpoints to be counted as to define the baseline. Okay, we just click OK. And then we can, again, drag this window to just cover this peak. Okay. Maybe a little bit. Okay. So right now, let's go to this the preference dialog of this tool. And again, you can output different parameters of each peak. Okay. For example, I just because I don't want the beginning and the end X, because we just assume this yellow window is fixed, the size is fixed. I want the area of the peak. I want the height of the peak, And I want the, okay, the centroid is also checked, and the width, okay, that's good. And another thing we want to check the where we want to output this result. So I don't want it to be put in the script window, and I want it to be appended to a worksheet. Just to check this box, okay. Once it's done, you can click apply and okay. Let's see how this will work. So in this case, we will apply the same settings to all the spectrum. So we can simply click new output for all curves. Okay, you see a workbook is generated. It contains the peak parameters for each spectrum, right? Let us make some more graphs. So basically, we want to see how this change with different parameter. Okay, let's go to basic 2D. Multiple panels. Let's do a stack plot. Okay. This plot gives us a sense of how the like peak width is decreasing, and you see the peak is moving to the right, right? And I can make some modification of the graph. First, we go to the property. Oh, sorry. Let's double click on this. Oh, sorry. Okay. Let's double click on the graph to go to the page level of this plot details dialog, and we go to layers tab. So I just want to customize the plot property of one page and of one layer, and I will apply those changes to all other layers. So I need to check the plot properties and the axis style box. So this is called common display. So when I check this, so any change in one layer will be applied to other layers as well. Okay. For example, I will use the mini toolbar to change the color of the symbol, maybe to red, and I'll change the size, change the symbol to be round, and increase the symbol size a little bit. And I can maybe decrease the size of the tick labels as well. And you see the change of one layer will be reflected to other layers as well. Okay. So now assume this graph is ready. Okay. And for example, if we want to now to check other peaks, okay, let's first to assume there's another, oh, sorry, assume there's another peak here. Okay, let's say. And we want to check the same like peak width, peak area stuff things on the other peak. What we should do? We can just move this yellow window to the to another peak. Then we click this new output for all curves button again. You will see 5 more rows are appended to this worksheet. Okay. If we, for example, we want to plot out these 5 peak parameters as well, like the graph here. So we simply, we can duplicate this graph, and we just need the last 5 rows. So I just deleted the unwanted rows. Then I can use this option called duplicate batch plotting. Okay, let's click this. So this is a very nice tool that you can duplicate a graph for the on other worksheet, or on other workbook, or on other columns. So in this case, I want to duplicate this graph with the other worksheet, which has the same data structure. Okay, so here batch plot with just choose sheet, and in this case, we know this new book name is here. Then I found this new book, and then on the result sheet, let's click OK. So you will see the the same graph is generated for different data. So this is a nice tool that help you to check the peak properties of different spectrum, and very easily. Okay, in this case. Okay, so if you have any questions, we have my colleague as our panelist. You can put your questions on the Q&A panel, and they will help you to answer it. Okay, so let's go to our next example. Peak integration. Okay, so in the last example, I give you the example on the peak integration on one single peak. Even though we have a multiple spectrum on the graph, and you can do it all at once, but you can do one peak on the spectrum at one time. So what if we have multiple peaks? If I just plot this graph, I want to get the in the area of each peak on the graph. And this graph has a very complicated baseline. I'm not gonna talk about the baseline identification here, but I will talk about that later. So assume we already have the baseline data, okay, in other two columns, okay. Let's use a different tool called peak analyzer. Okay, let's go with this tool. Let me bring in this window, okay. So a preview of the graph is shown in this window, and here in this panel, you can select a different goal you want to accomplish with this tool. So if you check a different goal, the different steps were shown in this upper panel to achieve this goal. So for now, I'm going to click Integrate Peaks. Okay. And in the second page, you choose which baseline mode you want to you will use to identify the baseline. So for this example, I'll just select Use Existing Data Set, and we will use column D as the baseline. Okay, so you will see the baseline is also applied on the graph, and you can I just subtract the baseline for now. Okay. Let's go to the next page. Okay, so at this page, I will try to find the peaks. Okay, let's start with the default settings. Okay, again, like 4 peaks are found on the spectrum, and you can use this decrease the threshold height to find more peaks. Like, okay. So some unwanted peaks, you want to remove it, right? Assuming this is this high peak, just one peak. I don't want these small ones. So I just uncheck this auto find box, and you can select modify and delete button, and you can select the peaks on the graph, and click delete key to delete these unwanted peaks. Okay. Click down to go back to this panel. And if you want to add these small peaks, you can also click add button to add these small peaks. Just simply double click on the graph to add peaks. Okay, so we are good now. And then let's go to next page. Okay, so this is a very sophisticated tool that you can adjust the integration range for each peak. So here, if you click on this adjust on preview graph, then you can resize the integration window. Okay, and you can also use the Z key to enlarge the graph horizontally to give you a like a fine tuning of the integration window. Okay, so these all looks good. Because Origin has a very clever algorithm to determine the range of each peak. Okay, we can just click the rescale button on the right to rescale. Okay, so once you're fine with each peak, and you can also define which parameters you want to get from each peak. Okay, and also specify the output worksheet in this case. Of course, you can fix the width for all peaks. If you have very nice peaks, then the integration range are all the same. You can click this button, but for our case, we just leave it as it is. And once we are finished, click OK, click Finish button, and it also generates the result sheet. Okay. Let's go to our next example, peak fitting. First one is the subtraction of the baseline. So once we have this spectrum like this, we want to subtract the baseline before we do a peak fitting. Okay. Again, we go to this, we'll use this peak analyzer tool. So here are two options: create baseline and subtract baseline. If you just want to get the baseline data, then you just use the create baseline. If you also want the spectrum after the subtraction of the baseline, then you can use this option. So we'll see both of them. So let's create a baseline first. Okay, so there are many ways to define the baseline. Some like automatic way, and some like a manual way. So this time I will show you the manual way. So we select user defined in the baseline mode. Okay, basically the idea is you put some anchor points on the curve, and these anchor points are either connected to create a baseline, or you know that those anchor points follow some curve function. Then you can do a fitting to fit a function to fit a curve to those anchor points. Okay, so now if you look at these, there are multiple ways to find those anchor points. Okay, so I'm not gonna go to details of each method, but if you want to know more, you can just press the F1 key to open up the help menu. It will gives you the details of each method. Okay, so basically the usual way to use is to second derivative. Okay, basically the where the baseline is usually the curve is more flat, and where the peak is, the curve is more like change significantly. So this second derivative way is just to find those flat area and find anchor points on those region. Okay, so if I keep the settings as it is, then I just click find. It will find some anchor points on the graph. You can use different way. You can add some more smoothing. So I just show you, if you add more smoothing, some points will go to the peak area. That's not what we want. We just leave that with a small value. Okay. Okay. Anyway, so if you are not satisfied with the anchor points, you can also manually adjust them. This is similar like we do the peak finding thing. Like you can click on the point and delete them, and you can also move the points up and down. Okay, and you can also add the anchor points to the graph. This is like a manual way. So sometimes people want to do like a batch peak analysis and want the algorithm to find the baseline. So in those cases, you'd better to let the algorithm to find the anchor points for you. Okay. So, yeah. So just to let you know that you can manually pick these points. Okay. once you are satisfied with you think okay, all these points are should be on the baseline, then we can click next. Okay, at this point you can see the baseline is added to the graph. Maybe some point is still not optimal. You can further modify the point. Once you move the point, you will see how the baseline is changing with it. Okay. For the baseline connection, now I just use like a straight line to connect these points. You can also use a spline to put like a smoother line to connect those points. Okay. Once you are satisfied with this baseline, you can subtract baseline, and again click this rescale button to show the spectrum. Okay. And you see the baseline will be output to a new sheet. Just click finish. Okay, so the baseline data will be output to this worksheet. So sorry that I did some testing before, so there's other extra baseline data. Okay, so the baseline is exported here. Okay, so let's see a different example. So this is the XPS spectrum, and so when you look at the spectrum, the baseline is kind of complicated. Okay, let's again go to the analysis, peaks and baseline. Okay, this time we'll choose a subject baseline. Okay, this time I will use a different method, the asymmetric least squares smoothing method. So once you select this method, another page is added to the steps panel. So you will see like by default the algorithm already find the baseline very well. So this the idea of this method is that the algorithm will treat the data points on the curve differently. So for those data points below the baseline, we'll add more weights to it, and the points above the baseline will put less weight. So combine the entire data sets will be used to determine the baseline. So this is like an iterative process to until converge, it will find the optimal baseline. Okay, let's see one parameter that you can change the asymmetric factor. So as it says, if it's a positive peaks, you should put it a value very close to 0. And for negative peaks, you'll put a value close to 1. So this method is sometimes very efficient, but it's not going to work for spectrum with positive and negative peaks, because it can only works for peaks of one direction. So another parameter you can adjust is the threshold. So this is defined to like how you treat the upper points and the lower points. So if I for example zoom in, you will still see the baselines cover some of the data. Okay, these areas might be good because these are noises, but here it seems cut off some peaks. So we can change this threshold to a lower value, and you'll see the baseline was moved downward, and now it's more only cover the baseline area. Okay, this is good. So let's click the rescale button to back. Okay, let's go to click next. Again, you can subtract the baseline. So the only difference of this compared to what we did above is it also generates the subtracted data. Okay, it's not just only generates the baseline, but also the spectrum after the subtracting the baseline. Okay, you can make a plot afterwards. Okay, Let's go to our next example, peak fitting. Okay, so this is another real data. If you look at this the spectrum, you will see like some strong peaks and some like tiny peaks on the both side, and there might be some like hidden peaks on the shoulder of the large peak. Right here, it might be another hidden peak. So we'll see how original are gonna fit these peaks. Again, we go to this peak analyzer tool. Okay, this time I will choose fit peaks. So this is our Origin Pro feature. So if you just have a standard Origin, then you don't have this feature. Okay, let's go to next page. So baseline mode, and this time I will use endpoints weighted. Okay. And because you're definitely sure that the endpoints are just on the baseline. So I can use this way to define the baseline. Let's go to next and subtract the baseline and go to next page. Okay, now is the peak finding page. So in this case, we are going to find these hidden peaks. So which means the local maximum method may not work in this case, right? If I just click find, I'd put some, let's put some smoothing because there are too many noises. Okay, so like this hidden peak is not found. And if after I doing smooth, this hidden peak also cannot be found. And we may want to lower the threshold in order to detect these small peaks. Give it a small value, 3. Okay, 3 is good. Okay, so if we can, sometimes when you want to find hidden peaks, you will use a different method called the second derivative. Okay, so if we check this box, and it will show the second derivative curve of the spectrum. And we want to do some, because it's too noisy for the second derivative. And I just apply some smoothing. And okay, so just turn off the noise, the second derivative. I just only leave the smoothest one on it. Okay, so we will see like if I just draw a vertical line. So these hidden peaks can be found because the second derivative is also show as a displayed as a dip on the curve. So that's why this hidden peak can be detected. Okay. So at this time, you may want to manually add some peaks. For example, this hidden peak. You just uncheck this enable auto find and click add. Maybe we want this tiny peak as well, and this hidden peak. Okay. There are other options, like you can put constraints of each peak parameters. You can apply bounds to each peak. I'm not going to show you here, and you can try that. Okay, now we go to this page. So Origin will run parameter initialization routines, and you will see the so initial guess of the peak parameters are used to estimate the fitted peak curve on the graph. Okay, so at this time I will show you this peak fit control button here. If you click this button, it will open up this this large dialog. And if you click this button, will show more. Okay. So I will just spend some time to explain this dialog. So there are multiple buttons in the middle. So this button will just to, if you click it, you can see it will show different labels on the spectrum. So right now, because I added the 2 peaks afterwards, so now the order or the index of peaks are amassed. So I will reorder these peaks. So I just click sort peaks. I want to sort the peaks by their center position. Okay, now it's good. It's check the center and ascending order and click OK. And I just click the reorder peaks button. So now the peaks are reordered. Okay. And another thing you noticed is this peak is not initialized very well. It's too broad, and this one is like too high. So we can like change the parameters before we do the fitting. Okay, so let's see. This is number 7. We just go to the 7th peak. Maybe we'll use a smaller area value. Let's have this area and make it higher. It's half the and make it okay. So now this peak is more follow the curve, and we can check the 8th peak as well. Maybe change the area as well. Oh, it's too much. Put wrong value. Okay, and yeah, maybe it's good. So the reason I'm going to I reset this initial parameters because the initial guess of the fitting parameters is sometimes very critical to get a proper fitting, and because the algorithm will search the parameter in a very large parameter space. If the initial guess is kind of far from the optimal value, the fitting itself will go crazy. So at this time, I just and I will show you some other things. Okay, I'm not going too deep, but for example, if you are fitting multiple peaks and you want to share some parameters, for example, you want you assume all the peaks are of the same width, you can you see here you can click the share drop down. For example, you can click the sharing, so it will apply it will use the same width for all the peaks. So it's a sharing option here. Okay, and you can also fix the parameters during the fitting, and you can check the fixed for any parameters in this case. And you can also use the different functions for different peak. So here's a drop down as well. You can choose other fitting functions. For now, I just use the Gaussian for all. Okay. Once it's ready to fit, you just click this button, and you will see this. It makes a nice fit for all the peaks. Okay, let's click OK. And if you are satisfied with the result, of course you have the options to. There's many sophisticated settings that you can change, like what quantities, peak properties you want to get, and which worksheet you want to export to, and then once you are done with it, click finish. Okay, it gives you a comprehensive result worksheet. Yeah, something you might want to check is fitting parameters, and also this ANOVA table tells you the how the fitting how are all the parameters are significantly different from 0, and it gives you the statistics table, gives you the R² value, so it's very close to 1, so indicates it's a very good fitting. Okay. Okay, now let's go to our next example. Sometimes the user may have the scenario that they have peaks on on a background. Well, this background, he knows this background follows a certain curve, and we can you can use the fitting regression to nonlinear regression to get the function of the background. Okay, and subtract that from the spectrum. Okay, again, we go to the analysis, peak analyzer tool. Fit peaks again. So in this case, we will use user-defined. And while these anchor points are already well-defined, so I just leave it as as it is. Okay, okay. So here, to define the baseline, instead of use interpolation or like connect these data points, we use fitting in this scenario. So by just looking at the curve, the baseline probably follow a exponential decay function. So I can select exponential decay. Let's see, exponential decay 1. Well, we can select exponential decay 2. This seems to follow the baseline even better. Okay. Then we click next. Here you have the choice to like whether you want to fit the baseline with the data, with the peaks. Okay. So I just check this box to, okay, so I'm not certain whether the baseline parameters are already optimal. So I want to fit that with the peak as altogether. Okay, let's go to next page. So the peaks are very simple to find, I guess. Okay, let's go to fit control dialog. You will see now the baseline is the exponential decay 2 function, and 2 peaks are shown here. And because we check the box to fit baseline with peaks, so these fixed boxes are unchecked by default. And okay, click the fit until converge button. So it looks like a nice fit. Click OK. Click finish. Okay, so it gives you the result of the fitting. Okay. Okay, let's quickly move to our next example. Of course, in Origin, you can fit 3D peaks as well. So basically, we use the tool called let's see, nonlinear surface fit. We use this tool to fit 3D peaks. Okay, let me bring up this dialog. So so in this case, I will choose the Gaussian 2D as a surface function. And if you look at this picture, it has like 4 peaks. Okay, so I just go to Advanced tab, and here is a replica. I will duplicate the peak for 3 times, and like you see 4 peaks are shown on the graph, but this one is not what we want because it's a negative peak. So I can change the peak direction to be just a positive. Okay, so now only positives peaks are found on the graph. So there's other parameters you can tune, but in this case, it's already initialized properly. So I just click the fit until converge button. Okay. Yeah, usually you just check this it tells you that the tolerance value of the e to the minus 9 is reached, means that the fitting is converged. You can also come to the message box here. If the fitting doesn't finish properly, it will give you error message on this in this area. Okay. So this example just to show you that once you have a 3D data, or you have like a surface plot, Origin can also use the Origin can also do surface fitting. Okay. Let's go to our last example, batch peak analysis. Okay. So in this example, so scientists usually have this problem like they have a multiple spectrum measured at different parameter. For example, in this case is a sample direction. So this is a ESR measurement data. So people put the molecule crystal in different directions and measure the power as a function of the magnetic field. Okay, so scientists want to study, for example, when put the crystal in a different direction, you will see the peak is moving, and they want to know the relationship between the peak position and the sample direction. Okay, so the normal way is bring up one spectrum and do a peak analyzer to get the peak position, and repeat that multiple times for other peaks, and then combine the result together to get the result. But that's a very tedious. So here I will introduce you the batch peak processing method that you can do all the peak fitting or at a batch. Okay, so let's first start with one spectrum and go to analysis, peak and baseline. Okay, so I will do a peak fit peaks. In this case, I will use a user-defined method to find the baseline. Just use this. These are all looks okay. I will use the let algorithm to find the baseline for each spectrum. Okay. Okay, at this stage, I will try to find the peak. So with the default setting, it only finds 2 peaks, and I will use, as I said, here's a hidden peak. So I will use a second derivative method, and I will put some smoothing. Maybe smaller. Okay. So the thing here is it might find many other peaks, unwanted peaks. Okay. So I will put some peak filtering method. So for example, I only want to find let's say by number. So I only want to find 3 peaks. Okay, let's see. Now only the 2 obvious peak and 1 hidden peak are found for this example. So assume we are fine with the settings. At this time, we can save the settings as a theme. Save as theme. Let's say my theme. Let's theme 1. Okay, let's save it. Save the theme. Okay. You don't have to finish the fitting for this spectrum because the settings is the setting already saved. You just cancel this dialog. Okay, then we are going to do the batch peak analysis. We can go to analysis, peaks and baseline, and batch peak analysis using theme. So here for the input, we have all the spectrum, select all the spectrum, and the theme, I just same my themes 1, and the result sheet, I want to the peak properties because this peak properties the worksheet contains all the fit the peak parameters. Okay, and I don't want to delete the intermediate result because I want to check individual fitting result to see if there's anything wrong. And the dataset identifier. So instead of showing the range, I want to show the spectrum direction and also the spectrum number. So this is the comments and the sample direction. Okay. So I want the result to be appended row by row. Okay, so here I choose the row in this case. So once done, I just click OK, and it will automatically analyze all the spectrum in the worksheet. Okay. So this is a summary worksheet. It contains, if you look at the summary worksheet, it contains all the spectrums and the peak parameters. Okay. And you can also check the fitting result one by one. So it all looks good. So the baseline is properly identified and the 3 peaks are fitted. Okay. Okay, looks all good. Then we can now, for example, I want to plot out the center point of each peak as a function of the sample direction. Okay. Let me change this to X and select the sample, the center of each peak. Okay, so make some changes. Okay, for the color, I can index the color with the peak index. So for each spectrum, I have 3 peaks. So I want to color these points by those index. So just click here by points indexing, then select the peak index. Okay. Then you can see the you have the okay, I can Control L to regenerate the legend. Okay, so I can, for example, rotate the graph. So if we compare these two graphs, you can see as the angle increases, the 3 peaks position are moving to the right. Okay, yeah, let's agree with the data on this on this graph. So the peak is moving right. Okay. Okay, so this is just an example to show you how to use the batch processing to analyze multiple spectrum all at once. Okay, and I think that's it for today's webinar for peak analysis. And if you have any questions, please feel free to contact us. Just send an email to us at tech@originlab.com or give us a call. And thank you for attending this webinar. Bye.